All right, so notice one thing I want to point out. My equal signs, notice they are lined up. So I'm going to check that on your work. Please make sure your equal signs are lined up. You should be able to draw like a line right through the middle. Okay, that's a good way to check that your equal signs are lined up. Okay, because one of the SLOs for this class is to be able to clearly communicate your mathematical concepts to me, the teacher. So, if your work is written out neatly, I can understand what you're writing. And it's also a lot easier to grade. Thank you. All right. So go ahead and try cross multiplication for B. Pause at C because I'm going to help you out with C before you start that. All right, so cross. That's going to be x3 or 3x equal to 4 times 1, which is going to be 4. All right, so writing that out in black again. So to get x by itself, you got to divide by that 3, because it's being multiplied by 3. You got to divide both sides by 3. And x equals 4/3. But, what if I said to you, you cannot answer as an improper fraction. You need to give me a mixed number answer. We're in trouble, because that is an improper fraction. But do not fear, we have already learned how to change from an improper fraction into a mixed fraction. Or a mixed number, sorry. So let's do that. To change this, we're going to do the division. 3 can go into 4 once. Subtract 3, and we get 1. So our answer gives me 1 and 1/3. So x equals the mixed number version, 1 and 1/3. And you could always check, did I do that correctly? Well, 3 times 1 is 3, plus 1 is 4. 4/3, yep. So at the moment, either one of these is acceptable because I did not say which version I want you to answer in, as long as they're simplified. All right. We have a problem, Houston. This is not a fraction equal to a fraction. This is a mixed number equal to a fraction. So first, I need to change this mixed number into a fraction. So let's do that. Multiply and then add. It's going to be 2 times 2 plus 1. 5/2 equals x over 6. All right, so notice we needed to change that into a improper fraction. So now we can do the cross multiplication. It's going to be 5 times 6, which is 30, equals 2 times x, which is 2x. All right, so we have 30 equals 2x. Notice my equal signs are lining up pretty well. Alrighty, and then got to get x by itself, so let's go ahead and divide by 2 to get x by itself. 30 divided by 2 is going to be, oh gosh, what if we don't know what 30 divided by 2 is? All right, let's go ahead and figure out how to do that by hand. 30 divided by 2, well, we can do the long division. How many times can 2 go into 3? 2 can go into 3 once. So then 2 times 1 minus 2. 3 minus 2 is 1. Bring down the next number. How many times can 2 go into 10? 5 times. Minus the 10. Ooh, look at that. There's no remainder. So our answer is just going to be 15. So 30 divided by 2 is 15 equals x. And there we go. Oops, I forgot to box my answer here. Please remember to box your answers. That's another way of showing your work neatly and being able to communicate your math. All right, so 1.3. So to reduce a fraction to the lowest possible terms, you're going to find the largest whole number that you can divide both the numerator and the denominator by. Okay, so this is what I was saying back in one of those problems. Let's see. Back here on 2.2. Sorry, 1.2, page 2, I said this is okay for now. So this is what I was talking about. This is not simplified. So we're going to figure out how to simplify this. All right. So we're going to reduce the first one. So my plan is I want to find out, is there a number I can divide 3 and 6 by? Yeah, they're both divisible by 3. So divide the top by 3, divide the bottom by 3. It's like the reverse building up property. 3 divided by 3 is 1. All over 6 divided by 3 is 2. Or is there any number that I can divide 1 and 2 by? There we go. We're done. All right, let's take a look. 12 and 15. What do you think can go into both of them? 12 and 15. 12 is divisible by 6, but 15 is not. 12 is divisible by 4, but 15 is not. Oh, 12 is divisible by 3, and 15 is also divisible by 3. Ah, the 3 pops up again. Okay, dividing that. 12 divided by 3 is 4. 15 divided by 3 is 5. 4 and 5, we cannot divide them by a same number, so we are done. 24 and 30, let's see. Oh, those are both even, so I could divide them by 2. 24 divided by 2 is going to be 12. 30 divided by 2 is 15. Okay, if we weren't certain how to get those, remember we can always do that division process I did here. Checking out how to get 30 divided by 2 and 24 divided by 2. Real quick, let's just do 24 divided by 2. Okay, 24 divided by 2. 2 can go into 2 once. Do the subtraction. Then bring down the 4. 2 can go into 4 twice. Do the subtraction. Answer is 0. So our answer would be 12. Awesome. All right, are we done here? Wait a second. That's the same fraction we have it up there. This can be simplified again. Huh. That can be simplified by 3. So that's going to be 4/5. Okay, so be careful. You may not always be done when you do your first value. So, actually, this means they were both divisible by 2 and 3. 24 and 30 are both actually divisible by 6. So I could do this problem again faster if I had noticed they were both divisible by a bigger number, 6. Okay? But don't worry, even if you don't find the biggest number the first time around, if you keep chiseling away at it, you'll get down to the same fraction. Okay, so either one of these methods are okay. Just if you work with smaller numbers, it's going to take you a little longer. All right, so let's see. D, 25 and 75. Well, if I'm thinking in terms of quarters, 25 is 1 quarter and 75 is 3 quarters. So 25 and 75 are both divisible by 25. $25 divided by 25 is 1. 75 divided by 25. Well, 75 is 3 quarters. So that's going to be 3. Okay, and there we go. We're done with that. All right, so 1.4, finding common denominators. So what is a common denominator? It is a number that is a multiple of all the denominators in a group of fractions. All right, so I want to find 2 common denominators of 1/2 and 2/3. Okay, so to do that, well, what I'm going to do is I'm going to take the denominator 2, and then I'm going to take the denominator 3. And I'm going to write out the multiples of them, okay? So multiples. So let's see, 2 times 2 is 4. So 2, 4, 6, 8, 10, 12, what is next? 14, 16. Let's just stop there for now. And 3, multiples of 3. 3, 6, 9, 12, 15. What else is that? 16, right? And we'll just stop there for now. So, common denominators. Are there numbers in the 2's that are the same as the numbers in the 3's? Yeah, there are. Look. A multiple of 2 is 6, and a multiple of 3 is also 6. So one common denominator one of them would be 6. Let's look for another common denominator. Oh, 12. They both share 12. So another one would be 12. And if we wanted to be overachieving, we could even say 16 was another common denominator of them. Okay, so that's just finding any old common denominator. There are multiple common denominators for pretty much any number. But sometimes we don't want any old common denominator. We want the lowest common denominator. So in math, a lot of the times you want to go with the smallest numbers possible because they're easier to work with. Okay, so the lowest common denominator is the smallest number that is a multiple of all the denominators. Okay, so for this example above, which would be the lowest common denominator? 6, 12, or 16? Well, lowest, think small. The lowest common denominator is going to be 6. Okay, that's the lowest common denominator. So if I was looking for that, I would have picked 6. So let's find the lowest common denominator of 5 and 6. Okay, so for 5, let's go ahead and do some multiples. 5, 10, 15, 20, 25, 30, 35, 40. Let's just pause there. Okay, multiples of 6. Oh, that started to go downhill. 6, 12, 18, 24, 30, 36. I think I have found our lowest common denominator. So the number that they share in common is 30. Okay, so that number is our lowest common denominator. That's the first one we found. So the LCD of 5 and 6 is 30. Alright, so now we want to find the lowest common denominator for these two fractions, and then convert both fractions into fractions where the LCD is the new denominator. Okay, let's do this step by step. So, 7 and 4, let's see. 7, 14. 7 times 3, 21. 7 times 4, 28. Let's see. 7 times 5 is going to be 35. 7 times 6 is going to be 42. 7 times... What am I doing? 7 times... You know what, let's just pause there. It's starting to get big. Multiples of 4. That's going to be 4, 8, 12. 4 times 4 is going to be 16. 4 times 5 is going to be 20. 4 times 6 is 24. 4 times 7 is 28. Look at that. We have the two similar numbers going on, 28 and 28. So right there, that's my LCD is 28. That's the lowest common denominator, 28. But the next step is we need to convert these two fractions into fractions where the LCD is the new denominator for each of these. So I want to make 5 over 7 look like something over 28. And I want to make 1 over 4 look like something over 28. Well, to make 7 look like 28, I need to multiply it by 1, 2, 3, 4. 7 times 4 is 28. So, I'm going to do the building up property. I need to do 5 times 4. And what is 5 times 4? That's 20. So I've converted 5 over 7 into a fraction with 28 as the denominator. These two are called, what? Equivalent fractions. Very good. Okay, so how do we make 4 look like 28? We're going to multiply the denominator by 7 to get that 28. And then I have to multiply the top by 7 using the building up property. And I get 7. There we go. Lowest common denominator. (1.5) Comparing fractions. All right, so our plan. We're going to order the fractions from largest to smallest, which means since the denominators are all the same, we're just going to focus on the numerators and decide which one of these are largest, and then so on and so forth. So the largest numerator is 6. So 6 over 7 comes first. Okay, that one's done. Which one's next? 5 would be the next one. 5 over 7. And then go ahead, see which ones are next. Yep, 3 over 7 would be the next smallest, and then finally 1 over 7. Okay, this one was relatively easy because they all shared the same denominator. So all we had to do was just compare the numerators. Okay, so to compare fractions that don't have the same denominator, okay, if they don't have the same denominator, we first need to create fractions with the same denominator. Then compare the numerators. Aha! We have just kind of did that. So here's our three fractions: a fifth, 4/5, and 3/10. I want to give them all the same denominator. So what would the common denominator of these be? Well, let's see. 5 and 5 are the same, but they're not the same as 10. But I know that 5 times 2 is 10. So my lowest common denominator is going to be 10. Okay, so to make that look like a 10, I'll multiply by 2 and by 2, and I get the fraction 2 over 10. Oops, sorry, that kind of squished in there. And then to make 4 over 5, have a 10, multiply that by 2, multiply the top by 2, and we get 8 over 10. All right, so now we've given them all the same denominators. So now, let's go ahead and take a look at this. We have 2 over 10, 8 over 10, and 3 over 10. So we're going to order them from largest to smallest. So now that they have the same denominators, I can focus on the numerators. Which one is bigger? The 8 is bigger. So 8 over 10. Then the next biggest one is 3 over 10. And the next biggest one is 2 over 10. All right, there we go. They've been ordered from largest to smallest. So remember, we needed to create a common denominator to be able to compare the numerators. All right, example 3, order from largest to smallest. Ooh, this one's even more interesting because we've got a mixed number and a whole number. So let's write these out separately to see. Remember, my goal is to give them all the same denominator. Let me write that a little farther away, because then we can actually compare their numerators. And at the moment, they do not have the same denominator, so that's going to be my goal. So my goal, common denominator. First things first, I need to make that into a improper fraction, so we're going to multiply and add. 8 times 1 is 8. 8 plus 7 is going to be 15, I believe. Yes, it's 15. That's going to be 15 over 8. 6 over 3, same thing, 2. How do I make 2 into a fraction? Well, remember, we just put it as 2 over 1. And then this value is still just going to be 2 over 8. All right, so what's a common denominator? We're looking at 3 and 8. 1, we pretty much just ignore 1 because that can be multiplied by anything. So 3 multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24. Multiples of 8 are going to be 8, 16, 24. Hey, look at that. We've got our common denominator, 24. So our lowest common denominator is 24. So we're going to create all of these fractions into fractions where the common denominator is 24. So that's going to be 8 times 3. 8 times 3 is 24. Oh gosh, what's 15 times 3? 5 times 3 is 15. 3 times 1 is 3 plus 1 is going to be 4. 45. Okay, multiplying for 3 to get into 24, we're going to multiply that by 8. By 8. All right, so 6 times 8 is 48. 3 times 8 is 24. Okay, same denominator, we're on our way. 1 times what is 24? 1 times 24. All right, what is 2 times 24? We don't know. Let's do it by hand. 4 times 2 is 8. 2 times 2 is 4. 48. Oh, it's the same fraction as that. Interesting. And the last one, we're going to multiply. Okay, it's an 8 again, so we're just going to multiply by 3 like we did before. And that's going to be 2 times 3 is 6 over 8 times 3, which is 24. All right, so the question is, we're ordering these from largest to smallest. The largest one is going to actually be 48 over 24. Okay, so we're actually not going to, well, I guess we can duplicate it. Why not? 48 over 24, 48 over 24. The next one down is going to be the 45 over 24. And then lastly, 6 over 24. So remember, the goal was to create the common denominators so then we could just focus on the numerators and compare the numerators. Okay, starting to get a bit more work going on these problems. 1.6. All right, so adding fractions. So we're still focusing here on fractions. Okay, so fractions must have the same denominator to be added. They must. I repeat, this is a big must. That's why it has been capitalized, and I will circle it a few times because, you know, that's important. All right, please go ahead and circle that. Tell yourself, fractions must have the same denominator to be what? Added. All right. Okay, so add the following fractions. Simplify if needed. All right, so let's see. Do they have the same denominator? Yeah, they do. So if they have the same denominator, you just keep the denominator and you add the numerators. So 2 plus 1 is 3. Okay, so remember, keep the denominator, add the numerators. 3 over 3, can that be simplified? Yeah, those are the same numbers, so this is actually equal to 1. All right, the next problem. Wait a second, that doesn't have the same denominator. That's a 5 over 1, and it's a 5 over 6. So I'm going to pick a same denominator. I want the 1 to look like a 6. Well, that's easy. I just multiply 1 by 6 to make it look like a 6. So do that building up property we've been doing. 5 times 6 is 30 over 6. Plus, and then bring down that original fraction of 5 over 6. All right, and that equals 30 plus 5, 35, and then keep the denominator. I've noticed the scar on my hand is really showing up. That's from a kitten of mine. I found a random wild kitten in my backyard. Okay, let's see. Can this be simplified? No. That is it. All right. So, next one. Oh, okay, so since this is addition, okay, because this is addition, what I'm going to do, remember how I said 5 and 3 tenths can also be written as 5 plus 3 tenths? So we're going to go ahead and do that. This is 5 plus 3 tenths plus 6 plus 4 tenths. So what we're going to do is add the whole number parts, 5 and 6. What's 5 plus 6? 5 plus 6 is 11. Very good. And then add the fractions. Do they have the same denominator? Yes, they do. So I can go ahead and add the tops. 4 plus 3 is 7. That's going to be 7 over 10. And there we go. We are done. So notice this method of how I broke this up, the breaking up method, works pretty much. It's simplest, and I would only really use it with addition. Okay, so when you break it up like that, we would use addition. All right, example 2, we're going to add the following fractions by first using the lowest common denominator to create common denominators. All right, okay, ooh, so we cannot add these. Why can't we add these? Because the denominators are not the same. We have a 3 and a 6. So a common denominator, let's see, that would be 6. So we're going to make that 3 look like a 6. So multiply by 2, multiply by 2, and we get 4 over 6 plus 1 over 6. Remember carrying the equal sign? Equal signs are lining up on the side. I'm going to be checking for that on your notes, please. All right, so keep the denominator and add across the top. So 4 plus 1 is 5. And, oh, B is just a duplicate of the top B. So we're going to skip on that one. That's a duplicate for some reason. C. All right, C. Okay, so since it's addition, okay, remember, since it's addition and these are mixed numbers, we're going to use that method we did above by breaking it up. So that's going to be, so actually try write that out. Write out the breaking up by yourself. All right, okay, so check with me on how you wrote out the breaking up.